Previously, we looked at what a linked list is. Now we're going to look at creating it in Java. Now, you can create in other languages. We're just using Java as an example. You can follow along to do it exactly in Java, or see the basic methods and properties you need to create in a different language like C++, Python, etc. So I'm going to create a new Java class. This class is going to be a linked list element. We're actually going to need two separate classes, and this is the first one. Now, the linked list element is going to have two properties. The first property is a value, and this value can be anything that we need it to be. It could be an employee, it could be a student, it could be a vehicle. To keep things simple, I'm going to create it as an integer. The next thing we're going to need to create is a link to our next element in our chain of our linked list. I'm just going to call it next. So this is going to be a reference pointer to that next element. Next, we're going to have our constructors. Now, the constructor we're most commonly going to use is going to be one that we're going to pass in a value to. So you can see that here. I'm going to set this dot value equal to value. And if you're not familiar with this connotation, the this dot references the property of our object that we're creating. The plain value is the parameter that was passed into our constructor. We're going to implicitly set this dot next equal to null. And we're also going to create one more just in case it's needed. The second one takes both the value and the next pointer, just in case we would need it. And you can see how we're set up here. Now, we're not going to worry about setting the value. We assume that once the value is set, in our case, we're not going to change that. So we're not going to worry about a setter for it, but we do need to have a method that's going to allow us to get the value. However, we will need to be able to set and get the next pointer. That way we can insert items into it, append them onto the end, etc. Now I can create a couple of helper methods that are going to make it easier for me to do my work with the linked list. An example of this would be, I want to know if I'm at the end of my linked list. Now, I have an ability to get the next item, and if my next is null, I can test for that. But remember, in an object-oriented environment, we want to treat each object as a black box, something where we don't have to know how the internals work. We don't have to know that it's a null value. It could be stored some other way. So we're going to create a simple helper method. So I'm going to create a simple helper method here. It's going to return a Boolean data type. And we're just going to check to see if it is the last element. I'm going to return this dot next equal to null. So here we do a conditional test. That conditional test is going to give us a true or false Boolean value. I'm going to take that value and return it. So this is a common way of returning a Boolean value. I don't need to do a if this dot next equals null, return true. I don't have to do that. I can do it right here. It simplifies my code, and this creates a nice little helper method that I can use in my main method. So I'm going to save this document real quick, and then I'm going to create the next class. And notice here I've created linked list. This is going to be my actual linked list class I'm going to interact with. The linked list element is going to be interacted with from within here. So my linked list class is going to have two class level properties. The first of which is going to be a linked list that's going to point to the very first element of my class. Sometimes this is referred to as my top, sometimes it's referred to as first. The second is also going to be a linked list element, and that reference pointer is going to point to our current element in our list. Next, I'm going to create my constructors, and I'm going to have a couple of different constructors with my linked list. So first, I'm going to have a default constructor, in which case I'm going to set this dot top equal to null and this dot current equal to null. I'm then going to have a linked list constructor. What happens if I get a value passed into it? So say int value, and what I will specify is this dot top is going to equal a new linked list element where I'm going to pass in a value. And then this dot current is going to equal this dot top. Remember, both top and current are reference pointers, so they point to a reference place in memory. We create that place in memory when we create the new linked list element, and now we have two pointers to the same location because this is the only item in our linked list. One more, and this is going to be if we get past any linked list elements. Once again, only having a single element makes this really easy to work with. So what are some common things that we're going to need to do in a linked list? Well, sometimes we'll need to go back to our first element, or the top element, if you would. So I'm going to have a So I'm going to create a goToTop method, and all it's going to do is say this dot current equals top. Now, since I don't have two tops, you might ask, why don't I have this dot top instead of? So you might ask, why do I not have this dot top? Instead, I only have top. Well, there's no room for confusion here, so this is not required. We can always include it, and a lot of places will encourage you to include it as a matter of their programming standards, just to make sure there's no confusion. So it's not required from a programming perspective, but it is good programming practice. The next method I want to create is one to find an element, and so we're going to see how we're going to do that. So I'm going to say public, and we're going to return a Boolean value if an element is found or not. And we're going to say int value. So with a linked list, I need to realize that I might be empty. And so I'm going to go and do a quick check on that. Now, the easiest way to actually do that is to have a helper method to see if I'm empty. So I'm going to create that because I can use that inside of my find. So public Boolean is empty, and I'm going to return this dot top equal to null. if this.top is equal to null, that means we have no elements. And so it would be empty and it's going to return true. Otherwise, it's going to return false. Now, my find method, how I'm going to use this is I'm going to say if not this dot is empty. So if I'm not empty, I'm going to go ahead and do this following set of code. Now, you might notice that this is giving me an error message, and this is because I'm currently not returning anything. So I'm going to come down here at the bottom and just say return false. Now, inside of our if statement is where we're going to check to see if we can find an element. If we don't pass that test and we don't go inside that if block, we're going to automatically return false. However, if we do find out that we're not empty, we're going to do something else. What are we going to do? Well, the first thing we want to do is we want to go to the top of our list. We have to start at the top and do a brute force search through our entire element. So I'm going to say this dot go to top. So could I say this dot current equals this dot top? You bet. However, remember, we're trying to keep this as a black box, even within our methods. We don't want it to think about how this is stored or how this is being used. We want this to be very flexible in our design structure. So that's why we're calling these internal methods. Since we know we have an element on our side of our list, we are going to use a do while loop. So I'm going to specify do, and then I'm going to have my while down here. So I'm going to go back and finish my while for just a second. I want to do that do loop logic first. So what I want to do is I want to check to see if the value of my current element is equal to the value that I'm looking for. So I'm going to specify if this.current.getValue is equal to the value that we passed in as a parameter, and if so, I'm going to return true. Now, if I'm not returning true, then I don't need to do anything else. I just need to move on to my next element. Now, inside my while condition, I want to check to see if I can move to the next one, and if so, do that. But there's not really an easy way to do that, or is there? Here's where another helper method is going to become very beneficial to us, and that is we're going to create a progress to the next element method. So I'm going to say public, and I'm going to return a Boolean data type, and I'm going to call it go next. Now you might be asking, why am I returning a Boolean value? Well, very simple. I'm going to see if I can go to my next element, because I don't want to go to where I'm going to have a null value. So I'm going to do a quick check. If this.current.is last element, okay? So if this is the very last element in our list, I'm going to return false, because I cannot go to the next element. Else, this.current equals this.current.getNext. This gets me my next element and sets it equal to the current value. Then I'm going to return true. So if I'm able to go to the next element, I will, and I'll return true. Else, I'm going to return false. Here, I can say this dot go next. And this gives me my Boolean value and progresses me if I need it. Makes it very, very simple to work with. The next common method I'm going to wind up using is a helper method to return the value of my current item. Now, I'm going to need to make sure I'm not empty, so I'm going to say something like int return value equals 0. And I'm going to return 0 if nothing happens. Okay, if I'm empty or whatever, I have to return a value, I'm going to return 0. Now, could I create my own exception, maybe a empty linked list exception or something like that? You bet. But I'm not going to for this type of simplicity. Now I want to check to see if I'm not empty, so I'm going to say not this dot is empty. And if I'm not empty, I'm going to say return value equals this dot current dot get value. And then I'm going to return that return value. That way I'm always returning a value no matter what. So I have a default value and I have a value if it's not empty. The next method I'm going to look at is going to be an add. So I have two different ways I can add. So first one is I'm going to add to immediately after where I currently am. Whenever I'm doing anything with a linked list, the first thing I'm going to check is I'm going to see if I'm empty. If I am empty, I'm going to take my element, and that's going to be both my top and my current. Now, what happens if we're not empty? Well, whatever my current next element points to, that's going to be the new element's next pointer. And then the element will become my current element's next pointer. So to do that, it's going to be real simple. I'm going to say element, the elem, which is my current element that I passed in with my parameter, dot set next. Well, what is the next pointer going to be? It's going to be this dot current dot get next. Then I'm going to say this dot current dot set next is going to be my new element. And I was able to very easily now add an element immediately after where I currently am. But I'm going to overload this. So what happens if I want to be passing in that value? So it's not a linked list element, it's just a value. In our case, it's an integer, and it's real simple. I'm going to say this dot add element, where I'm going to add a linked list element. But I'm going to say new linked list element based upon the value that we have passed into our parameter. So very, very simple for us to use. Now, what about that append? Well, good question. Public void. And we're going to append an element. Now, what we'll need to do is we'll need to go to the end of our list. And an easy way to do that is going to be create a special method that will take us to the end. So I'm going to come up here real quick and say public void go to end. You might say, okay, well, how am I going to do this? Well, I'm going to say wow. This dot go next. And this is going to be a simple little while loop. I don't need to do anything inside of it. It's just going to say, can I go to next? Yes, I can. Let me go to the next element. Can I go to the next element? Oh, I have something. I'm going to do it. That go next checks and goes to the next element if I can. When it can't go any further, it's going to exit out of the while loop. So this is a very, very simple method for us to use. Inside my append element, I'm going to say this dot go to end. So now I'm going to be on my last element. And then I'm going to specify this dot current dot set next is equal to my element. So this now makes it so that the current last element now points to this new element. Now, these are some of the most common methods that we're going to run into. There is one more that we may need to use in reference, which would be a public void remove element. And this becomes an interesting question is, do I remove based upon an integer value or a link to the reference? And in reality, I probably need to have both methods. So I'm going to say int value. I'm going to go to the top, so I start back at the beginning, and then I'm going to create a linked list element called previous, and that's going to equal this dot top as well. Now you might say, well, why do I have a previous element? Well, if I'm going to remove an element from the center, I need to know what was pointing to it so I can redirect it to what the next one was. I'm going to do a quick check. If this dot current dot get value is equal to the value I'm searching for. This is a special case because it's for the very top one. I need to remove that top. And so what I'll do is I'll say this dot top equals this dot top dot get next. And then I'll say this dot current equals this dot top. So we have to do a special case because we would have to remove that very first element. Else, now we're going to go in and do anything else that we need to do. We know it's not our first element, so I'm going to kind of do this while loop that we saw before. So I'm going to say, okay, I'm going to go next if I can. And inside of here, I'm now going to check to say, okay, if this dot current dot get value is equal to value, previous dot set next is going to equal this dot current dot get next. So we're going to change where the previous element pointer was and point it to the next one. Now, if we did find this element, I'm going to do a break as well. This is going to break us out of our while loop, which is going to finish off the else statement, which is going to exit us out. If we are not breaking out of this block of code, then I'm going to need to set previous equal to this dot current. And that way we're going to go through every element in our list. We're going to check to see if there's a match. If there's a match, we're going to remove it. And then if not, we're going to update what the previous value is so that we can update it later on. Could I have a check for if I'm looking for a linked list element? You bet. It'll be a little bit different because I'm going to have to check to see if this dot current would equal to the element that was passed in. But I could still use this same basic logic. It's not as likely to do that, so we're just going to use a remove element based upon the value that is pushed in. And that's the basic process of how you need to create a linked list. We can test this out later on and verify that it's working. You can look at it. There are some additional helper functions that you might need for your own special case, but those are the core ways to get it up running.